Hello, my name is ALINA and welcome to my course Fundamental Concepts in the Architecture of an Electric Vehicle. Today we will continue with Module 2 entitled High Voltage Concepts and Components. All staff working in automotive maintenance and repair industry face a big problem nowadays. They must perform operations in vehicles equipped with either internal combustion engine or electric engines, or cars that both have an internal combustion engine and an electrical motor. For this purpose, the entire staff of such an organization need to be educated on the main components of an electric car, their classification, and their high voltage systems. So, after reading this module, you should be able to understand the concepts of high voltage in electrical vehicles, understand the stages of electrification, identify the components of an electric vehicle that have high voltage, identify the functions of high voltage components, identify the most common faults on high voltage components. Keywords: high voltage, hybrid, electric fuel cell, converter, inverter, battery management system, electrification stages, thermal management systems for batteries in electric vehicles. Table of contents. Today we will speak about high voltage in electrical vehicles, stages of electrification, electric car components, functions of high voltage components, and the most common faults encountered in high voltage components. First of all, we will begin with the concepts of high voltage in electrical vehicles. These are the most common abbreviations that you must learn by heart, because you will see them in a lot of technical literature and in all manufacturers' documentation. So please look at them very well and try to understand all of them. Let's remember, in automotive industry, high voltage refers to voltages above 60 volts direct current. So at this level, the need for contact protection becomes mandatory. Please refer to Module 1 and remember the safety rules when working on electrical vehicles. So, the International Electrotechnical Commission defines a hybrid electric vehicle as a vehicle with numerous types of energy sources, storage or converters, at least one of which is electrical energy. But on a simpler definition, we can understand that a hybrid electrical vehicle is a car that has at least two alternative fuels. One could be electricity, or better said, must be electricity, and the other one can be another form of fuel, like hydrogen or gasoline. Sometimes we have hybrid electrical vehicles that have diesel fuel, so please be aware of this. In this table, we will see exactly the differences between a hybrid electric vehicle, an electric vehicle, and a fuel cell electric vehicle. We can say that they are all electric vehicles. Why? Because let's say for a range or a period of time, they can run only on electrical energy. When we are referring to full electric vehicles, we will call them battery electric vehicles. Okay? So, we can see that the table contains the definition of the said vehicle, the batteries, structure for and below we can see a sketch, a very simple sketch to understand exactly how they work. Please try to read this table and try to understand very well all the notions explained here because they are very useful. Further on, I will show you the stages of electrification. Namely, we will see that, like I told you before, electric vehicles are of several types. They can be battery electric vehicles, plug-in hybrid electric vehicles, hybrid electric vehicles, fuel cell electric vehicles, and not so very common extended range electric vehicles. We can see in the table below, let's say, a few functions, a few features that are common for electric vehicles, and we can also see the differences between a hybrid electric vehicle and a full electric vehicle. Here, where we see electric vehicle, we can see that they run 100% on zero emissions. So that is a very good news for us. And here in the table we can also see their battery voltages. So we can see that a hybrid vehicle, a micro hybrid electrical vehicle, has a voltage of 60 volts. So it is a high voltage component here. Moving on, we can see in this picture the electrification of the drivetrain. Starting from a conventional vehicle. A conventional vehicle is known as to be a car that has an internal combustion engine that works with gasoline or petrol. It's the same thing. So we can structure the other types of drivetrains starting from this ICE engine that runs on gasoline. So we have hybrid electric vehicle, plug-in hybrid electric vehicle, range extended electric vehicle, and the cars that pollute the least, battery electric vehicle and fuel cell electric vehicle. Their drivetrain is entirely run with electricity, so they no longer use any type of fossil fuel. Moving on, we will try to identify the electric car components that have high voltage. So we must be very careful every time we work with them. Please always remember the safety rules. Refer to the safety rules every time you will start working on a high voltage component. So a few notions to remember the components of an electric car, and here I will try to enunciate the most important elements that have high voltage: traction battery pack, electric motor, motor control unit, power distribution unit, PTC heater, electric AC compressor, onboard charger, DC-DC converter, manual service disconnect, high voltage wiring harness, and charging port. We will try to speak about a few steps that technical personnel must follow. And when I say technical personnel, I refer to the people that are not mechanics, but are the people that receive the car, that order parts, that speak with the clients, and they also must have, let's say, an idea about these notions, because they will also work with this type of notions. Please, every time we have an electrical vehicle, or maybe sometimes we don't know that it's an electrical vehicle, so the first thing we must do is check the vehicle identification number. This number is given by the manufacturer, and or will always indicate the model specification, such as the use of high voltage electric system. Logos, trademarks located on the exterior or engine compartment of the vehicle indicating use of EV technology. For example, a lot of BMW cars use the letter I to show that that car is an electrical car, either a plug-in, either a battery electric vehicle. So each manufacturer has a letter that tells you the car has high voltage system. On the interior, instrument cluster, power meter, battery surveillance device located on the dash. Check owner's manual. Check the battery area of this vehicle in IDIS. IDIS is an international dismantling information system. It's a platform that you can find on the internet, and it shows you exactly how to dismantle the battery traction pack every time you have an electric vehicle. So please check the website mentioned here, and you will find very interesting information there about electric cars and about the battery packs. The functions of high voltage components. Of course, this module does not want to show all the functions and the components of high voltage systems, but you must know a little bit of them, and if you want to know more, I'm sure that you will find it on the internet and in the bibliography that you will have at the end of the module. So please be aware, the traction battery pack could be individually packed battery cells or integral battery systems. The electric motor. The electric motor is crucial for the operation of an electrical vehicle. It generates the power that makes an electric vehicle go, and it is responsible for converting electrical energy into mechanical energy. Motor control unit. MCU is an electronic device that controls the operation of an electric vehicle. It controls how much electricity flows through an electric motor. It controls the speed and torque of an electric motor. It monitors various conditions such as battery voltage and temperatures and so on. You can see here how the MCU is divided into drive control, speed control, direction control and brake control. So it is a very important part of an electric vehicle. Power distribution unit. The PDU is an assembly of various components that provide power to various parts of an electric vehicle. A PTC heater. A PTC heater is an electric heating element that uses a positive temperature coefficient ceramic resistor to generate heat. Electrical AC compressor. The electrical AC compressor is powered by an electric motor and works together with other parts such as condenser and evaporator to provide a comfortable environment for the passengers. Of course, the AC compressor has other functions that are stated here. You will all read them and try to understand them. Onboard charger. The OBC is a key component that converts the AC input from the grid into DC and determines the charging power and efficiency of an electric vehicle. It monitors battery voltage and current and manages communication between the vehicle and charger. DC-DC converter. The DC-DC converter is an important high voltage component of electric vehicle that converts high voltage DC power supply to low voltage and vice versa. The main functions of a DC converter: supplying power to electronic circuits, adjusting input voltage or output voltage, connecting different voltages together, stabilizing the voltage, changing unregulated voltage into regulated voltage. Manual service disconnect. The electric vehicle is equipped with an MSD that can be used to safely disconnect the high voltage battery pack from the vehicle. MSD is recommended for use in situations such as when require access to the battery pack for safety reasons. High voltage wiring harness. The high voltage wiring harness is a critical part of the drivetrain system in an EV. It carries power between the battery pack and motor controller, as well as other high voltage components. Charging port. The charging port is an interface between EV and the charging station. It allows the EV to communicate with the charging station via EV charging cable, receive power from it, and communicate with the grid. We have several types of ports: Type 1, Type 2, SS, CHAdeMO. The most components fall in the high voltage components. Due to their harsh working environment, various types of faults can occur in the motor and its drive system that can degrade system performance and reduce the reliability and safety of an electric vehicle. Also, the battery pack usually comprises in hundreds of cells connected in series and parallel configurations. Different types of faults, including battery abuse and actuator and sensor faults, may occur in battery systems, resulting in battery degradation and accelerating agent. EV failure, dangerous accidents. It is reported that 30% of EV accidents are caused by battery faults. We have common electric motor drives faults. You can see them in this sketch. We have common battery faults. You can see them in the sketch below. It is very interesting. And good job! You have now completed Module 2. After reading this module, you can understand the difference between types of electric vehicles. You can identify the main components that carry high voltage and their basic functions, and a few types of faults that could interfere with the good performance of an electric vehicle. And now, I'm sure you will be glad to find a little assessment of Module 1 and 2. Please be aware, these are notions that you really must know, and they will help you in your everyday activity. Please find a few items to complete here. Then you will have the key answers. And thank you for watching this presentation. I hope you really find it helpful, and I hope to see you next time for Module 3. Bye bye!